code in Python myself. I've done programming in other languages, but not in Python. And I do have a lot of experience with NLP, but this is going to be very introductory, so I hope you're going to learn something and you're going to get excited about this field. So just a couple of words about myself. I've done both a master's and a PhD in this area, but I got into this whole field through linguistics. Very early on, I decided I want to become languages was interested me, and so I decided to become a translator. So I enrolled at a university in Ukraine, which is where I'm from. And I looked around the room, and there were hundreds of mostly women wanting to become translators, and I thought, there's no way we need that many. And then a year later, I was in a course, Mathematics for Applied Linguists, and the professor said, you know what, there are those people who create translation tools, so computer programs that would translate text automatically. And I said, well, I thought to myself, well, that means I'm basically trying to become a professional in a field that's going to be done by computers. I better be joining those other people. So I've done this, and I haven't regretted ever since. It just has been a wonderful journey. And I am an author of an open source algorithm called MAUI, and I started working on it when I came to New Zealand about 10 years ago, and working with open source has actually made my career. I recommend it to everybody to try your hand at it. It's not that scary. After graduating, I worked for a company called Tinger here in Auckland, and 2 years ago I started my own company doing consulting and now software development in this area. So this is what we're going to be talking about. Just a recap about what we know about NLP. You said you don't know anything, but I bet you know if you just think about all the science fiction books and movies you've heard about. And we're going to discuss how advanced are we actually now with technology today. Then we're going to talk about all of the difficulties behind working with language and work through different Python libraries, how to do different NLP tasks. And I'll give you some hints of what to do next. So, fiction versus reality. Many of you have watched Knight Riders, and there is this car called Kit. He's very humorous, he has a dry sense of humor, and easily offended. So it has a personality. So how far are we to actually a talking vehicle? Well, here is a picture from Android Auto, something I've seen at the Google I/O conference, not this year, but last year. So very soon, pretty much every car will be with this technology inside it, and you will be able to talk to your car and say, where's the next, when is the Auckland Museum open? And then take me there. So it will know from the context that you meant the Auckland Museum and will give you directions. And I already use, when I'm driving and I search for an address, I would use the Google Voice to actually help me navigate there. And it does understand my accent.
It does?
Yeah. We're going to try something for sure. Translation. Well, those of you who have read Hitchhiker's Guide to the Galaxy may remember this thing called babblefish, very odd creature that you put into your ear. And after that, you are able to understand everything what people around the universe are saying in all of their languages. Pretty cool, although I can imagine uncomfortable. The closest thing in real world is an application called WordLens. And I think that now this is part of the Google Translate, where you just hover your phone over a headline, and it would automatically translate it into a different language, and it would match the font used. And this is what makes it a bit futuristic. They call it augmented reality translation, and it does work really well as a party trick you can do. So not as far as bubblefish. But then there is this video, and maybe I'll let you Google and watch it, or maybe there's time later and we'll watch it in the end. But basically, these two ladies using Google Translate to order food from an Indian restaurant in California, but in Indian. So they prepare all the things they would say, and the food arrives. So if you Google slime extra spicy, then they check, is it actually really spicy? When we talk about search, there's this in Star Trek, the library computer, and it uses sophisticated AI to answer people's commands. So obviously the answer in real world to this would be Google, and I'm just going to do a small test. What is the weather today in Auckland?
Today's forecast for Auckland is 14 degrees with rain.
What about Wellington?
Today's forecast for Wellington is 14 degrees with rain.
Are there any good restaurants around here? And I did this from home last night to just double check, and it suggests, and I live on the shore, and there is a closer McDonald's to my house, but they still suggested I should go to Key Street. I thought it was suspicious, and then I did this. Closest McDonald's.
Here are the listings for closest McDonald's.
And I think now it thinks that I'm in at home, so it suggests to me that closest to me would be, because it knows where's home. So
it's light and you're supposed to be home. It's light and you're supposed to be home.
Yeah, exactly. Well, on Google Maps,
yeah.
Home is set up. So yeah, it's pretty much very close. Now, where's my presentation?
Cool.
Yeah, and I couldn't watch it till the end. It's pretty boring. Basically about this guy falling in love with an operating system, and this operating system called Samantha. She speaks in Scarlett Johansson's voice to start with, and she's also super available and always interested. So in reality, we have this guy, Joshua, who tried to do the same thing with Siri, and she said, my end-user licensing agreement does not cover marriage. And doesn't that remind you of Kit with the dry sense of humor that Apple programmers have put into Siri? So yeah, no luck in love so far. So let's talk about our language and why is it complex to build such systems? Why have we not yet achieved the perfect science fiction? Well, language consists of many different layers, and when you talk, you don't realize how complex it is actually. So it starts with phonetics and speech sounds. So any system that is designed to understand human text, human speech, first of all needs to understand the speech sounds and differentiate them from other sounds. There is no meaning at this point, there's just the sounds. The meaning comes when we look at phonemes, which is the area of phonology. And different phonemes have different meaning, and then they together build words. Morphology is the study of how words are created. So in English, you would have different endings like ing. So if you add ing to run, you would get running, so that the meaning changes. Syntax is how you build sentences and phrases. And semantics is all about meaning. It could be meaning of words, it could be meanings of sentences. And pragmatics is a very cool one. Does anybody know what is pragmatics? So imagine you're out. Since most of you are guys here, I'll give an example. you're out with your girlfriend, and she's saying, "Oh, it's cold." What does she actually mean? She wants your jacket. Or she wants you to close the door if you're inside and it's drafty. But she says it's cold. So what she says is actually doesn't mean what she actually is saying. So imagine a computer trying to figure out something complex as this. So all of this needs to be encoded, and it's super difficult. So there are some people here who said that they're pretty good with Python. And let's say, and please, those who know some NLP don't answer. But let's look at sentences and at a similar task as finding words in a sentence. Any suggestions how you would do it in Python? What command you would use?
Split.
Split.
Yes.
And then you split at
Spaces.
its faces.
Yeah.
What if your sentence is in Chinese? Are there any Chinese speakers? Would it work?
It's hard, so require NLP, right?
Yeah, it would require NLP because there's no white spaces.
No spaces.
And there's many languages like this where even as simple as this, figuring out where are the words is not straightforward. You basically need a segmentation algorithm to identify the boundaries. And you can use a dictionary, but it's not going to be accurate, so you need a more complex algorithm. And even in English, if we look at a sentence like this, is it really a good idea to split at white spaces? Can anybody tell me why it's not a good idea?
Hot dogs have space in the middle, but it's actually sort of one discrete.
Exactly. Hot and dog separately mean something completely different. If you split them, you're gonna just lose the meaning. And the same thing with Charles Feldman and Coney Island. These are named entities that ideally you want to keep them together as one unit. So even in English, there are complexities. So now that we have the words, assuming that we know the words, let's think about how a computer looks at these words and how it can figure out the meaning. So if we look at something like CAN, anybody?
Double meanings.
Yeah, so what kind of meanings?
Tin and
A tin can and the verb.
yeah.
How would the computer figure out? And then if we, and we will find out in a moment, I think for now we're just going to keep it a secret. Planes. Sounds like a simple word, pretty obvious, but it could mean the airplane, the geometric plane, or plane the tool. And in order to find out what it means, computer will need to look at the context, like flying is an indicator that probably planes is the airplane.
No, if you throw wooden planes around, they are quite dangerous.
Yeah, good point. And yeah, the whole sentence, flying planes could be dangerous, again, could mean what you just said, or could mean these two different things. The activity of flying planes is dangerous for the person flying them, or the objects are dangerous. Hello. So let's get into NLP with Python. So you're just in time for the good part. First of all, what kind of things we can do with text? And here are some examples. So we can extract keywords and text, and this is what you do in your work you mentioned. We can categorize in a more generic way where we know what are the predefined categories and what a text can be categorized as. You're going to see some examples. You can extract entities, like in that example, Coney Island is a location, or you can have biochemical entities, protein names. You can then redux them, which is where the text with black spot. So if the text is sensitive, you can automatically redact names of people who should be not disclosed. You can identify sentiment, which is the mood that the author is conveying in the text, and the genre as well. So it could be a romance, or sorry, a novel, or a news article, or a legal document. You can automatically do all of these things using Python. So NLTK has been mentioned, and it's a tool called Natural Language Toolkit, and it's I highly recommend it to anybody who hasn't done any NLP, because it's really, really simple to follow. There's a book, but there's also an online tutorial, and it comes with this tool. You can see a screenshot here. It's basically a shell that lets you download resources important to working with NLP. These resources could be corpora, and corpora is plural for corpus, and a corpus is a data set, basically. So when you work with text, you need some data, and they already have some data. Some of it is annotated. It means humans have looked at it and said, here's my sentence, here's my next sentence, or here are my part of speech tags or entities, so that you can actually test how accurate is an algorithm. And then you need models, and models are kind of basically tools that were created using annotated data sets to help you solve a task. So I think it's just too complicated, but if you just try using it, you will understand. So if we do something, a very common task when you work with language is to identify the core words or keywords. And you start by looking at words that can be removed. And these words can be called stop words. So stop words are words that don't change the meaning of a sentence if you swap them around. So even the acting in transcendence is solid, with the dreamy depth turning in a typically strong performance. The same thing can be expressed using the same core words, but very different stop words. I think that transcendence has a pretty solid acting, while with the dreamy depth turning in a strong performance, as it usually does. So all the blue stuff can be ignored. How do you do it in Python? In just a couple of lines. So this is in a Python shell. You import your stop words, which is a data set that comes with an LTK, so you don't need to think about what kind of words are stop words. Then you initialize stop words for English. It works in other languages. And your sentence is best to represent as words. And then when you say print all of the words that are not in the stop word list, it prints you the 4 words. So pretty simple. So here's our can example. The way for a computer to differentiate can as a verb from the tin can is to use parts of speech. A part of speech is a category of a word. So flying is an adjective, planes is a noun, can is a verb, be is a verb, dangerous is an adjective. Here, how Python is used to figure it out. In NLTK, you just import the NLTK. You can tokenize your sentence into words by using a command called word tokenize. Okay, I said flying is an adjective, but it's a special kind of cross between a verb and an adjective. But you can see here, each word is printed out along with a part of speech tag. And for can, the tag is MD, which stands for modal verb, a different kind of verb like should or would or can. Or, this basically says there is no way it can be the tin can. And the way the algorithm behind it figures it out is by looking at the context. So if can precedes a verb be, it is more likely to be a modal verb because it's just very common in English language, can be as a combination. Again, very simple. I love Python for working with language. It's just ideal.
Be great for doing lesson homework.
So there's a statistical model behind that, is it? And that's
Yeah.
just the most likely.
Most.
And the grammar rules.
Well, there are different approaches, and they're all like in the 90% of accuracy. So 95, 98, they're all competing to get the 100.
Right.
But it's actually not that complicated to write one.
So you don't get a score.
I think because NLTK is open source, and if you dig deeper, you can get the algorithm and print out the score. I've done it before with other tasks where I needed the score to actually to modify the code, but it doesn't by default. It just returns you the text. So TF-IDF is a statistical technique. Statistics is used a lot in natural language processing, and this one is used a lot in information retrieval as well, so in search engines. It helps you figure out words that are particularly important in a document, because a stop word list cannot capture all of the words that are non-important. It kind of depends on your data set. So, for example, if you're looking at all of the news articles, the words that can be ignored could be very different ones if you look at a medical data set, for example. And TF-IDF captures this by combining the frequencies of words in documents in this formula, which multiplies term frequency, which is how frequent is a word in the current document, compared to the document frequency of that word in the collection. You don't need to be able to implement this, because this is how simple it is to do in Python. And here I used a different library called Gensim, excellent library for doing statistics in NLP-related tasks. But I did use NLTK to get some movie reviews, because I just wanted to use a data set with multiple documents. So we have a variable text, and we put all of the words from the movie reviews as lists of words into this list of lists. And this is what we use to initialize a Gensim object called dictionary. I call it dictionary here. Then a couple of commands later, we have the TF-IDF model. And this is an example of a model you can download using NLTK for other tasks. But you can also create one, either from a data set like movie reviews or any other data set. It doesn't even have to be annotated in this case, because it's just statistics of words. So now that we have the model, we can ask, so what kind of IDF score, inverse document frequency, have these words? And you can see that something like film and movie, because it's used a lot by people writing movie reviews, has a very low score. And something like Jolie, as in Angelina Jolie, has a very high score. So if you have a movie review and it has a lot of mentions of film and a lot of mentions of Jolie, you can use this value to offset the term frequency and bring Jolie to the top. The next task is categorization. And again, this is where statistics use, and TF-IDF is something that's useful, again, to weigh each word that appears in a document. And when you have all of these weights for all of the words, you can create a multi-dimensional space where each dimension is a word, and each document is a vector represented in this space. So for simplicity reasons, only 2 dimensions are shown here, 2 words, and 2 documents, and a third document or a search query, for example, and you a text categorization algorithm. In NLTK, you can use the ones that they have, such as naive-Bayes classifier. You can basically figure out, given a new document, which category is more likely to belong to. So if you have news articles and you've known before that these are all of the articles in the entertainment category, and these are in the politics category, and then a new article comes in, Obama and hangover start rate, insults and interviews, this piece of code could help you, just 4 lines, could help you figure out that this is kind of in between entertainment and politics because it's similar to both of them. How it can be practically used for a very useful application. Have anybody heard of 50 Shades of Grey or read the book? So this is actually an image from Economist, and it talks about how there's only 13% of pages that talk about sex, the most interesting part, right? I apologize, children in the room. So there was this researcher who decided, well, I actually want to find those 13 pages automatically. She used, I think she used NLTK, and automatically categorized all of the pages with an accuracy of 93%. And somebody else posted on Twitter, "Hell yeah, this is the only way to read this crap." Sentiment analysis. Let's say we have movies and people give movie reviews. They give them different number of stars, and this can translate into sentiment. So a low number of stars means the person did not like the movie. It's going to contain lots of really negative comments. And if it's 10 stars, they're going to be all excited about the movie. So sentiment, I use here a different Python library called TextBlob, and TextBlob is a wrapper around NLTK and other libraries, just to make it simpler to do NLP tasks. So here, again, only 3 lines to find out sentiment in a sentence like, I love this library. You get the polarity value and the subjectivity. Polarity is the actual positive negative, and it ranges from -1 to +1. And subjectivity is, is the person saying something about their own opinion. And in this case, it is quite subjective. So I went to IMDb and I took reviews of this movie and put them into text files. Yeah?
How would this deal with something like sarcasm in a line like that? Like, would that be considered in the results of sentiment?
So the algorithm that TextBlob is using is dictionary based, so it does not consider sarcasm at all. It just says, well, love is a positive word, and library is a neutral word, and then it just averages them. It's pretty simple. There are more complex algorithms. Do you know those jokes? Tony loves them. That's what she said, or that's what he said. So there is a PhD researcher who actually wrote a paper about the computer algorithm that automatically can attach to every sentence this range. So one form of sarcasm or humor. Yeah, any kind of interesting, cool thing you can do with language, there's going to be a PhD researcher working with it. But what amazed me, even TextBlob is a very simple approach, and I did not train it on anything. It just worked out of the box so accurately. You can see that the scores returned are in the same order from most negative to most positive as the stars, and it didn't know anything about how positive the movie review was. It's surprisingly accurate. I want to talk about more complex applications. So when you take these tasks and build them into more specific application to solve a particular problem. So let's say you are a, what are these people called? Like a movie producer, and every day you get stacks and stacks of movie scripts, and you need to very quickly identify, will people love this movie or will they not love this movie, and you just don't have time to read. So something you could do is let your interns scan and OCR them, and then extract keywords from each of these scripts to figure out, does it match your interest? I've done the similar thing with the movie reviews, and you can download the tutorial that walks through the steps, which involves getting rid of stop words, using TF-IDF, and some more things. But basically, if you have this movie 4 rooms, these are the keywords you could extract with Python, and it's not much code at all, and it's pretty straightforward. So our quiz for you: what makes a successful movie?
Venta.
So one of these columns is extracted from negative movie reviews, and another from positive movie reviews. So if you have a script and it matches keywords in this column or in this column, it kind of tells you how people are going to take it. So is it positive or negative?
Positive.
Positive.
Have a vote. Get everyone to have a vote.
Okay, let's vote. Who thinks this is positive?
Yeah.
And who thinks it's negative? Yeah. Yeah.
The other one.
The majority wins.
Explains a lot.
That's Mars.
Batman. Who doesn't like Batman? I mean, come on.
That's right, exactly.
I don't know. I think people love Batman, but it always depends on the interpretation. There are so many versions, right? And
They probably keep on saying this is nothing like Batman.
George Clooney.
so here we have a problem sorting out through movie scripts, and a solution how you can do it using Python. Another important task. This is somebody else's project. This guy, Ben Fields, said he just loves craft beer, but it's just so hard to decide. You come to a shop and you basically have bottles, and then you choose based on the design. Wouldn't it be nice that instead of this, you have a menu where each of these beers would be described in terms of its characteristics? Turns out you can get a lot of reviews of craft beers. Even most obscure beers have hundreds of reviews on this site called beerreview.com or something. So he took all of these reviews, downloaded them. You can see it's all text. So if people saying bottled, a hazy dark golden beer with a huge yellowish head, the aroma has notes of fruits, lots of spices and caramel. This is just one person's comment. You really want an aggregate of what most people think this beer is like to decide whether or not you should try it. So what he did was he removed the stop words, and then he counted the frequencies. But and I'm not sure even if he used TF-IDF, but he found that this was for a particular beer, from review for a particular beer, but the things repeated. So you have coffee and espresso, which are kind of the same. You don't want to put all of these into the same review because people don't have time to read that much. Or dark and black and brown is the same thing, cocoa and chocolate. You really want to make this more succinct. So he used Gensim, another library I mentioned. And what Gensim can do is categorize words into what they call topics. And each topic is basically a dimension that, using pure statistic, just can be extracted from text. So as a result, he then had the name of the beer and 4 most important topics. And then he argued in his talk that, well, it didn't work 100%, but in many cases, each of these 4 corresponded to the ingredients of a beer. So you make it out of hops and malts and yeast and water, right? So another cool application. I promised a story about neurolinguistic programming. So I was fortunate to go to a conference in California where so many really cool people were invited, including Andrew Ng, who is a machine learning and NLP guy from Google who now works for Baidu, and he's one of the people I follow and look up to. And there was the creator of the Russian search engine called Yandex, and I thought, well, such a great audience. What you could do there at that conference is run your own session. So I decided to run a session on NLP to get a chance, all of these people in one room, and kind of talk with them. And I called my talk, "Are we NLP? Are we there yet?" ? So I'm in the room by myself, waiting for people to show up. And the first person who comes in is a guy who runs a music festival. Because they're all introduced in the beginning of the conference, and I knew that he's not a computer scientist, not a linguist, nothing related to this. And I'm like, so you know this is about natural language processing? And he goes, really, not neurolinguistic programming? And I thought, what have I done? So I said, well, you know, it's also very interesting. But he's like, no. There was another session. I was just tossing in between them. I'll see you later. So he left, and then the next person comes in and goes, is this natural language processing? And I said, yes. Oh, thank God. And all the people started pouring in, including Andrew Ng and all the other people. And they all were really relieved that it was natural language processing that we were talking about. And this was, I think, 4 years ago. And yeah, the question was, is this technology actually viable enough, even though it's so futuristic and even though there are so many complexities in the language, to solve real-world applications? And the conclusion was, yes, it is, particularly when you use a lot of statistical data-driven techniques. And this is what Google does. They have so much data that they can create perfect translation tools, perfect search, or nearly perfect. And something they've mentioned is deep learning. So 4 years ago at that conference, deep learning was as the thing to do in NLP. And only, I think, 2 years ago, it started to come up in the media as a new trend. The good news is you can do it in Python. There's a library called Piano, which lets you do deep learning. So these are libraries that I recommend to try out. NLTK for really basic stuff, Gensim for statistical operations on large document collections, TextBlob for sentiment and other things. Scikit-learn is a very good machine learning library. And now I remember that this text, the 50 Shades of Grey project was using Scikit-learn. It's basically like NLTK, but for machine learning. In just a couple of lines, you can do complex stuff, and you don't need to know how machine learning works. So if you want to know more, follow me on Twitter. And you can check out the video from last year, and there's also a tutorial link that I mentioned before, where you can go through the code and try things out. Any questions?
So, good application for this might be
kind of like with spam detection. You would build a classifier to decide troll or not troll. And you would, the key with classifiers is to decide what actually would make the algorithm decide. And with spam or not spam, it's often about what words are used. And then you can include in your set of features other things like I don't know, what do trolls normally look like? I think they create those fake accounts with 0 followers, so that could be another insight. So some of the information could come from things that they're actually saying, and another information could come from other signals, non-textual ones.
What do universities use to process essays to make sure they're not a copy? What do they use?
So like plagiat detection.
Yeah. Is it a natural language type tool they use?
Yeah, so I think they look at similarities in how phrases are structured, because if you're smart, you wouldn't copy the exact sentences, but you'd mix up them a little bit, maybe change the stop words. So strip the stop words, and suddenly you compute the similarity, basically, between two documents. So similar to duplicate detection, and similar to search, in fact. So when you search for something, except your search query is not a couple of words, but the whole document.
So when you're running over large data sets, can the Python library handle running over several computers, or is it single processor? How does it make those large data sets?
I think Gensim specifically is designed to scale over multiple, scale well over multiple cores. NLTK is really a toy library, so if you, for example, that movie reviews data set has 2,000 short texts, quite short, and to